In this video, we are going to discuss simple hill climbing algorithm, and in this video, we are going to discuss all the important points about it. So we will start simple hill climbing algorithm. First important point is it is local search algorithm. That means it has got knowledge of its local domain, but it does not have any knowledge of the whole global problem. Second is a greedy approach. That means until it is getting best move, it keeps going on going. So as it will stop getting the best move, then it will stop over there. And third number, backtracking. If it is not getting any best move, then it cannot do backtrack. So we'll go ahead and discuss this with an example. So over here, there is a simple algorithm, just we are starting within the initial state. So we will start any problem from initial state until we do not get any solution. So what we are doing, we are finding a new operators, that is a new node. If we see over here with a simple example, then this is my initial state ahead of which I have started. Suppose A is a starting node and there is a children node of a B, C, or D. So that means ahead of which I have three states. That means it has three branches. Now from those three branches, that is B, C, D, based under heuristic value, based on their cost, whichever method we are based on their heuristic, and we have to which is the best from all these and all these three nodes. That means B, C, D. So it will explore this ahead. It will forget others, and that means neither we are saving them in the memory. So this was the best form. Then so we explore this ahead. Now let's say we have a three problems ahead. Now these are the three branches as we got ahead, that is B, C, D. Now let's say if this is the base form there, the three, then uh, then uh, then we can this will be this will be a explore ahead. So you forget this the simple concept of simple hill climbing algorithm. So this line is the most important. If the state is better than the current state, then it is a new current state. Look at this diagram. If I am moving from this line, so this is our initial state. I will start from this initial state, and after that, I will get the better result from each and every state. So that's why I'm climbing up, not climbing down. Okay. Um, mm, that means you keep on going until you are getting the better state. Till then you keep on moving ahead as you stop getting better state. So from there you cannot do backtrack. It works in a very simple way because what is its name? Hill climbing. What is the meaning of hill climbing over here? That you are simply climbing a hill but blindfolded. Blindfolded means you have tried a cloth on your eyes and you are climbing a hill. In that, what is the best move? That we have until you are going on a height, until you are climbing up. Till then, you will you will keep mm, on climbing. If in the middle somewhere you feel that your leg is going downwards, then you will not go there until your leg is going towards up. So you keep on slowing the best move at the point your leg will be stable. That means neither you can go down or up, so you will go there um, and stop. So that is the best path for you. Over here, you went till this path, so you have achieved the maximum value over there. Over there, all the problem over there here is which we are going to discuss ahead. So this example I already told you over here. Just to save the time, let's see over here. This is the problem. In this is the starting and this is the go state. Suppose so. This is the starting and this is the go state. Suppose. Go state. Now from starting state, I have three. I have two option here, B and C. Okay, so I can move towards any one from these two. But now what I have to check the heuristics value. Now when I check the heuristics value, of this state S to B is 4 and S to C is 3. Okay, so what I have to do is I have to select only one, which is the best. That means from those two, which is my current state. This so which one is the better than the current state, and you just have to focus on this line. If the state is better than the current state, then see which is the better form of two. Mm. So if B is better, we'll move on B. If C is better, we'll move on C. So here we can see that C is the best path to move. So above the two nodes, we'll choose the C node. Okay. Towards this side, I will forget. I will forget. Um, I can say that. So this is equals to is the is this better? No, it's a heuristic value is more. So we want less. We have to reach to the goal state in the minimum cost. So which one is the better state? This one where we will it move. So that is I will show we will move from starting node S to C. Okay. Towards this side, I will forget this. Neither we are saving it in memory, because in case of already yesterday algorithm, I will show that in case of the base search algorithm, we always connect searching one node and keep the other nodes in memory. But in A-star algorithm, we have to search all the nodes and find the value of heuristics, which is heuristics value and the path value. That is the function of fn is equal to gn plus hn. So that's why we find the better option. So that's why in case of the base search method, we can find that whatever the path we will get after the base search method, okay, or straight line or equilibrium, so that not gives us the minimum cost. So other path will given the minimum cost. So that's why the A-star algorithm is here to find that particular thing. So that particular concept is over here. So over here in the hill climbing problem is local maximum. What is the meaning of local maximum? We can see the value which is a local maximum. So what is the what is the meaning of the local maxima? As I told you right now, that you are going blindfolded because you have got knowledge only of local domain. So if you are blindfolded, then you will have knowledge of the whole domain. You will come to know that is the mount, that is a mountain. This is also one mountain. On this mountain I have to climb. You will be able to see the whole view, but over here you are not able to see the complete view because you are starting from this position. So this is the your highest point, not this point is highest. So after reaching that point, you will see that that is the highest point of the mountain. Okay. So, on one point you will reach on a stable state. So after reaching there, neither your legs towards up or not towards down. Then there, what do you feel? You feel that so you will come to know that is the mountain. This is also one mountain. On this mountain I have to climb. So you will be able to see the whole view, but over here you are not able to see the complete view. I already said that because you're working on the local search. So what is there in the local domain? You are climbing blindfolded. You are climbing the mountain. What is the base move? Base moves. The base move that you can say that the base move that until you can reach that particular point. That particular point. So that there is another hill, there is another hill. Um, so after reaching there, neither you legs towards up or not towards down. Then what you feel that you have achieved the goal state. So I have reached at the maximum value. So as you remove the blind fold from your eyes, then you feel that wow, I have reached or I have achieved the maximum value. But there is a problem. What can be the problem? That there is another hill. There is another hill whose height or value, whose height or value another which height or you can say value is maximum than the uh, previous one, the maximum. So which can be seen over here in this diagram. But now you cannot but you cannot achieve this why? Because it works until you get better state, their current state, from their current state. So you have already achieved the maximum value over here. So now we will not go towards minimum because to go over your first, you will have to go towards minimum. You will have to go down, so this will not go down. So although if we want to solve traveling salesman problem or we want to solve 8 queen problem, it was good in some problem because over here the place complexity is less. We are not keeping all the state in the memory, we are just keeping the base state in the memory. So we are removing the others, so until you are getting the base, till then it's good. That means this whole value depends on the heuristics. If you are getting good heuristics, then you will keep on moving. But over here, the local maximum means you achieved the maximum, but it is that globally maximum. No, this is not a globally maximum. So this will not be achieved. So this is the concept of what you can say. This is a problem called local maximum. So over here, also I have shown you this problem. Although this problem is a theoretical part only. Whatever here I am explaining you with an example. What is the meaning of local maximum? You have started from a state. Your heuristics value is something. What is the value of the current state? So you need better value than this. Obviously, better value means you want to reach in less heuristics, in less cost. So which one you will select from others, the which have the minimum cost, that is selected. Obviously, you selected least one, so you will so you will remove this. You do not save in this memory. This is also not saved in the memory. So my space complexity over be better because we are going towards only one best move. Not, let's say, you explore this ahead like BFS or DFS. So when you explore this state, now your current state is something like you can say in previous example C. So now then on this current state, you explore new state. This is taking me at our goal state. That means your heuristic has increased. So what is the question telling over here? Algorithm is telling if it is better than the current state, then it is new current state. So over here, our new current state will not be formed because heuristic value has increased. So this will stop over here only. So that is called a local maximum problem. Then Plato. The next picture says the Plato. The Plato, or which is called the flat maximum. Actually, these words are based on hill climbing only. What is the meaning of hill climbing? When you are climbing, then you got a flat point. Flat point means where your neighbors. That means all the neighbors that you have, let's say, value of the every node is same. Now, at this point, whom will you select? When all are giving you same heuristics value, then which one you will select from them? So in this case, also it does not give you any answer ahead. So it stop over here. So is also one of the problem of plateau or flat maximum problem in the hill climbing. And third one is ridge. What is the meaning of ridge? When you have a multiple values, see over here, you will be able to see clearly in 3D diagram. So after going that problems reaching in one direction, you are climbing over here. You keep on climbing until you get the best move. And what is the meaning of the best move? Until your legs is towards front, it is towards up. That is the best. What means you are climbing the mountain? You reach at a point. You are remove your blindfold over here. That means I have reached at the maximum value. Now, obviously, after this minimum value will start, so you will not go there. But what is the meaning of reach? The between the point, suppose this point and this point. So, suppose this is the A point and B point. B is above A, so A now, this B is above A, but now after reaching over here, it will not change the direction because starting of the hill climbing, I already said that it's not a backward direction or backtracking. So it will not change the direction. Let us not changing the direction. It is moving in one direction only. So although B point is above it, but you cannot reach on that because it is only moving in one direction. Although is a special case of local maximum only. So this is all about the hill climbing problem. Thank you.